Okay, this video I will go through your WA3 pre-WA3 practice paper set 2.1. Okay, so you should see this question. Okay, let's do the MCQ first. A lap car is loaded with different masses and move at the various velocity. Which diagram shows the cart mass system with the greatest inertia? Now, inertia, the larger the mass, the larger the mass, the larger the inertia. The larger the mass, okay, the larger the inertia. So I should be looking at which cart having the greatest mass. So it is D. Okay, which of the directions shown below allows you to turn the rod with the minimum effort? Okay, so they tell you that it's turning, and you see this, which is actually the pivot. Alright, so it should tell you that it is a moment question. But how about minimum effort? Minimum effort, does it mean minimum moment or minimum force? So effort, you learn, is actually a force. So which one allows you to turn it with the minimum force? Okay, let's look at D first. So D, the line of action of the force of D actually passes through the pivot. So for D, the perpendicular distance is 0. Okay, how about A? Okay, for A, we need to actually draw the line of action of force for A. So for A, it will be this way. Okay, so you have to extend the force. Okay, some of you still don't know how to extend the force or when to extend. So if you don't know, don't care, just extend the force. So once you extend the force, and this is the pivot, right? So what is the perpendicular distance? So let me ask you, if you are at this point, at pivot point, and I ask you to run to this dotted line with the shortest time, would you choose this path, or this path? A, B, or C? The answer should be A, because A is actually the shortest path. And if I were to be able to draw the shortest path, I should get it as a perpendicular line. Okay, however, if just now you didn't draw your line of action of force A, you will tend to make this mistake of doing this, but this angle will definitely not be 90 degrees. Okay, so I stress the importance of drawing your line of action of the force. Okay, so if you are in doubt, don't care, just draw and extend the force line. Okay, then use the example that I told you, running from that point to the line in the shortest distance, and that will definitely be the perpendicular distance. I'm sure you learned this in math as well. So now let us try to apply this in B. So I'm using green color for B. So first thing that I do, I don't care, I just draw my line of action of the force B. Okay, so imagine now you are at this point B, and I want you to run to the line in the shortest time. So you will of course take the shortest distance. So it will something like, it'll be something like this. Okay, it'll be something like this. And when you find the perpendicular distance, you can actually get a 90 degrees. Okay, so if you're still not sure, I would actually maybe ask you to use a ruler. Okay, the ruler, so let's say this is my ruler. You place it on the edge here, you place it over here, you place it on this line, and you slide your ruler, until it actually touches the point, Okay, so do ask me to show you in person if you don't understand. So I say this again, you put a ruler, okay, with your edge touching this line of action of the force, and you slowly slide it until eventually it touches your pivot, the point. And when it touches, this will be the perpendicular distance. Okay, so how about we try this for C? Let me erase everything first. Okay, so for C, I will first draw my line of action of the force for C. Okay, let's say I'm not sure how to get my perpendicular distance. I draw my line of action for C, and then I put my ruler against this line. Okay, so of course the ruler has a rectangular edge that will give me my 90 degrees. But is this touching the pivot? The pivot is here, not yet. So you keep sliding. Okay, it's still not touching, and you slide until it touches, and this is actually the perpendicular distance of C. Alright, so now that you know how to find the perpendicular distance, I'm going to mark out all the perpendicular distance for A, B, and C. Okay, I'll be using different colors. Okay, so for A, I'll be using green. So the step involved will be draw the line of action of the force first. Draw it. Okay, and then use your ruler, put it at here, put it at here, right? And once you stop, once it touches the pivot, this will be the perpendicular distance for A. Okay, this will be the perpendicular distance for A. For B, okay, I draw my line of action of the force. Okay, and I put my ruler. Once it touches the pivot, okay, that will be my perpendicular distance of B. Okay, so the line of action of the force is important. So for C, it is actually this distance. So you notice that A is definitely shorter than B. Okay, how about C, the perpendicular distance of C? Imagine this is our right angle triangle. DC is actually a hypotenuse. So DC is definitely longest. So DC, the perpendicular distance of line of action of C to the pivot, is the longest. Now recall, moment equals to force times perpendicular distance. Okay, so if let's say all of the, to turn this rod, I just need a constant moment. I can actually, by having the largest perpendicular distance, my force will be the minimum, right? The least effort, the least force. So answer will be C, because for C, it actually has the largest perpendicular distance, right? So if I set the criteria that the rod will just turn with a certain moment, then the force with the largest perpendicular distance will be the least force required. Alright. Okay, question 3. Equal masses of water are poured into 4 jars. Which jar will the pressure exerted by the water on the base be the greatest? Okay, so this is actually trying to look like a liquid pressure question, but actually we should go back to the basic, which is pressure equals to force over area. Now if they give us mass, it is not your force, it is not the weight. I need to actually do one step. Weight is equals to mg, where mass is multiplied by gravitational field strength to give us the weight, which is actually a force. Okay, but a lot of people like to think that mass is equal to force. It is not. Okay, so now they all have the same force. They all have the same force. Now they are asking for the greatest pressure. So the greatest pressure will come when area is the smallest. So the answer will be B. The contact area with the floor is the smallest. Okay, now another pressure question in MCQ number 4. They have the same weight. Please read this. They have the same weight. This is quite different from our tutorial question, whereby they say the sides are all doubled. okay, that means the mass is multiplied by 8. But in this case, they specifically tell us that they have the same weight. Okay. Okay, so continuing, cube B actually has sides that are twice as long as cube A. So they're asking us for the ratio of the pressure exerted on the ground by cube A to cube B. So can I say that A, pressure of A over pressure of B is actually the ratio. But what is the pressure of A due to? It is due to the weight of A over the contact area. Now for the base of A, it is actually x squared. Okay, and the pressure of B is due to weight of B over the contact area with the ground, which is actually 2x multiplied by 2x, so it's 4x squared. Okay, 4x squared, yeah. Now, since they have the same weight, I can cancel them out. Then I do my math manipulation. I will keep this as denominator, but this will become the numerator. So it becomes 4x squared over x squared. Now, x and x I can cancel out, so it becomes 4 over 1. Therefore, the ratio of PA to PB is actually 4:1. So answer is A. Okay, now move on to the structured question. A man with a parachute with a total mass of 60 kg, please annotate this will be the mass, jumps out of a moving plane. Figure 1.1 shows the VT graph. So what's important about VT graph? Gradient represents acceleration, and the area under the graph represents distance traveled. Okay, so we may need these two concepts later. Now, gravitational field strength is 10 Newton per kg. All right. So, question A part 1, state the man's acceleration at t equals to 0 seconds. So when he first jump out, his acceleration must be 10 meter per second square due to Earth's gravitational field strength. They need us to explain in terms of forces. Okay, so when he first jump out, what are the forces acting on him? Okay, initially when he first jump out, there is a weight. Okay, so this weight is due to gravitational attraction on him. Okay, so is there any other forces acting on him? He hasn't started moving, so there's no air resistance. So therefore, the F net is equal to weight. Okay, now what is weight? Weight is due to mass times gravitational field strength. However, this gravitational field strength is also the same as gravitational acceleration, which gives it a value of 10 meter per second square. Okay, so if you don't know why these two are actually similar in values, can I ask you, for gravitational field strength, the units are Newton over kg. What is the unit Newton for? It is for the physical quantity of force. Okay, what is the unit for of kg for? It is actually for mass, correct? Now for force, the formula is F net equals to ma. All right, so over m, so n and m can actually cancel, so it becomes acceleration. So acceleration's unit is actually meter per second square. So these two are actually similar. Okay, that's why sometimes we say 10 meter per second square, sometimes we say 10 Newton per kg. On the moon, it is the G is 1.6 Newton per kg, meaning somebody on it falls, it will experience an acceleration of 1.6 meter per second square. Okay, so how do we answer this question? Explain in terms of forces. When the guy first fall out, okay, we draw the free body diagram. Okay, the only force acting on it is weight, and since weight equals to mg, which is and also since g is the acceleration, he will have the acceleration of 10 meter per second square. Okay, just to show you the answer, at t equals to 0, weight is the only force acting on a man, right? F net. Thus, the acceleration experience will be equal to the gravitational acceleration or acceleration due to gravity or gravitational field strength. Okay. Now, determine the air resistance acting on the man between point W and X. Where's point W and X? It is over here, right? What do you notice? The gradient is actually, the gradient of the graph is 0, right? It is a flat line. Therefore, the gradient is 0. It is not you cannot say that the gradient is 0 because it's a straight line. You must say that the gradient is 0 because it's a flat line. There's no rise. If the gradient is 0, and what does the gradient represent? The gradient represents acceleration. So at this point in time, the acceleration of the man is 0. That means he's moving with constant velocity of 70 meter per second, right? However, all this doesn't really answer our question because they wanted to know the air resistance. So why is it that the acceleration is 0? When acceleration is 0, it means the F net is 0. Okay, this is what we got from the graph. Acceleration is 0. So you must also think back, when there's no acceleration, F net is equals to 0. Let's go to our free body diagram again. So this is W, and actually W, if I can calculate, is equals to mg. The mass is 60, the g is 10, therefore it is 600 Newton, right? So are there any other forces acting on the man? There is air resistance, okay, AR. So the air resistance actually opposes the motion, right? Now these two forces together combined will give me F net to be 0. Therefore, air resistance must be equal to 600 Newton, and it must be in the opposite direction so that these two can cancel each other out to give me a value of F net to be 0. When F net equals to 0, acceleration is 0, which can be seen from the graph, right? Because the gradient is 0 and gradient represents acceleration. Okay, now at which point does the man open his parachute? Now what's the purpose of the parachute? Is to slow him down, right? Slow him down by creating a large surface area in contact with air, right? So that it will increase air resistance, okay? And when that happens, he will be slowed down. So we look at where he's slowing down. So he should be slowing down at X, okay, at point X. Now still explain the motion of the man in terms of the forces acting on him between X and Y. So at X is where he is opening up the parachute, So when he opened up parachute, okay, so this is the answer. Let me just annotate from here. The parachute opens, causing the man to undergo deceleration. Okay, why did he undergo deceleration? Maybe let me draw my free body diagram. Okay, now the weight of the man will more or less be constant, right? Because his mass is the same. Okay, but the air resistance now increases. It must be more than the weight, right? That is the purpose of the parachute. The parachute is to open up, increase the surface area in contact with the air so that I can increase the air resistance. So now you see that actually the F net, it is upwards because it's AR minus W, right? However, the motion is downwards. The motion of the parachutist is downwards. So this F net of going upwards is opposite to your motion. If it's opposite, it will cause him to decelerate. Why will he decelerate? Because as long as there's F net, there will be, you think of acceleration, right? As long as there's F net, there's acceleration. But why did it become deceleration? Because it's in the opposite direction as motion. Opposite direction of motion. Opposite in direction to motion. Okay, so now if my motion is this way and F net is in the same direction, he will accelerate. Okay, this you know, right? If you are traveling in a certain direction and you decide to accelerate, you will be moving faster in that direction of the motion. But now if your Fnet is opposite to your motion, he will decelerate, okay, because it's opposite in direction. Okay, now this is a confusing part. As he decelerates, his velocity will decrease, right? Correct? Deceleration brings about a decrease in velocity. And this is important, the air resistance acting against him decreases. Now this is not difficult, right? As you move faster, if you move faster, there will be more air resistance. But as you slow down, the air resistance acting against him decreases. So previously I drew like this. After a while, due to his speed decreasing, the weight remains the same, yeah? The air resistance will now be of a lower value. Can you see the length of this? Right? Why did the air resistance decrease? Because his speed decreases. Okay, his speed is decreasing, therefore air resistance is decreasing, and eventually W and air resistance will be equal and opposite to one another. Okay, they have always been opposite, but eventually they'll become equal because throughout this motion, his velocity is decreasing. Throughout this motion, his velocity is decreasing. Alright, so come back to this answer. As he decreases, the velocity decreases, therefore the air resistance acting against him decreases. Therefore this leads to a decrease in the Fnet. Okay, so according to Newton's second law, when Fnet decreases, deceleration decreases. So you can see from the graph here, it is actually going from steep to gentle. The gradient is decreasing. If the gradient is decreasing, that means the acceleration is decreasing. But mind you, this is a negative gradient, so it is a deceleration. So the gradient is decreasing, so it is decreasing deceleration. Okay. Now, how about y and z? Y and z is what I have talked about in this last part. Eventually, your air resistance is equal to W, right? The air resistance keeps changing. The air resistance keeps decreasing because of the decrease in velocity. Okay, so how do we phrase our answer? Okay, y and z, the air resistance is equal in magnitude but opposite in direction. Alright, so Fnet is equals to 0. So according to Newton's first law, he will move with constant velocity. So how do we solve this kind of question whenever they ask you to explain using forces, right? You must always talk about Fnet. But how can we see what is the Fnet? We must draw a free body diagram. The free body diagram can help you to visualize how the forces are interacting with one another. So once you see how the forces are interacting with one another, then you can go on to do your Fnet. When you have your Fnet, then you can go on to see whether is it accelerating or decelerating or constant velocity. So actually this is the sort of answering template. I say again, draw your free body diagram to show whatever forces are acting on the object, right? Then from then on, you can determine for yourself, is there Fnet? If there's Fnet in the direction of motion, acceleration. If there's Fnet in opposite direction to motion, deceleration. If no Fnet, then constant velocity. Is actually very fixed way of answering questions. Okay? So question 2, alloy is a mixture of 2 or more metals. One alloy is made by melting 4 cm³ of a metal A. So can I just put this as VA of density 5 gram per cm³. So this is density A. I also need to check the cm³ and cm³ correspond. So later on there's no need to change anything. Then 8 cm³ of metal B. So this is my VB and this is density of B. Okay, assume there are no changes in volume as the alloy is made. Calculate the density of the alloy on Earth. They want us to find density. Okay, I don't know why they give us the G, but let's see. Okay, so in order to find the density of alloy, right, we need to calculate total mass of the alloy over total volume. Okay, so the total mass, now density equals to mass over volume. So let me calculate mass of A first. So density A equals to mass A over VA. Density A is 5, mass of A unknown, volume of A is 4, therefore mass of A is 20 grams. Let me repeat for B, equals to mass B over volume B. Okay, so density of B is 6, mass of B is unknown, volume B is 8, so mass of B is 48 grams. So now I have 20 plus 48 over total volume will be VA plus VB, so 4 plus 8. So do your math and your final answer is 68 over 12. So answer will be 5.67 grams per cm cube. Okay, so there's no need for the G to be involved. Okay, now question 3. How do you know what kind of question is it? I spot a pivot, okay, and I spot in equilibrium as I'm reading, therefore it must be a moment question. So for moment question, later on we'll do using our 6 step, okay? But first, they want us to, on figure 4.1, draw all forces acting on plank AB, on plank AB. Now this student is pressing down on plank AB, so this is weight of student, okay? There is a force over here, so this is normal force by pivot, normal force by pivot. Okay, then this is weight of counterweight. It is pressing down on the plank. Furthermore, the plank has a weight of 80 Newton. Now we take note that the plank is uniform. If the plank is uniform, means the CG is in the middle. CG in middle. How long is the plank? The plank is 2 meters. So somewhere here, okay, so this is the 1 meter mark, this is the 0 meter mark, this is the 2 meter mark. So this is the weight of plank. Okay, so draw all forces acting on plank B. We have weight of student, weight of plank, and weight of counterweight. Okay, and this is all balanced. So total downward force must be equal to total outward force. So there's only one force that's outwards, and that's the normal force by the pivot on the plank. Now state the principle of moments. You should memorize this. Now calculate the weight of the student. Now weight of student is WS. I need the mass of student and I need the G. Now what is the mass of student? Is it stated? No, it is not stated, right? That means I cannot use this formula. Okay, I cannot use this formula. Okay, so that means we have to solve using pivot moments method. So the first step is, where's the pivot? So the pivot is here. Okay, then second step, how many forces do we have? How many forces? Okay, we have WS, we have normal force due to pivot, we have weight of plank, we have weight of counterweight. Okay, step 3, based on where the pivot is, what are all the perpendicular distance of the line of action of each force to the pivot? So WS is here. Okay, the student stands 0.3 meters from NA. Okay, the pivot is 0.5, so I need to actually fill in all the distance. 0.5 meters. Okay, it's getting a bit messy. 0.3 meters, and this weight is actually 1 meter. This counterweight is 2.2 meters away from B. 0.2 meters. Okay, so we have to work out all the individual perpendicular distance of each force to the pivot. So for the weight of students is simple, it's just 0.3. So can I just write 0.3 over here? How about the normal force? What is the line perpendicular distance of the line of action of this normal force to the pivot? You notice that the force that the pivot exerts on the plank, alright, is at the pivot. So the perpendicular distance is 0. Okay, how about the weight of the plank? If here is 0.5, that means weight of plank, the line of action, the perpendicular distance of the line of action of weight of plank to the pivot is 0.5. How about for the counterweight? So we have 0.2 here. The distance here is 0.5. 0.5. This is 0.5, right? So 0.2, 0.5. So will be 2 minus 0.5 minus 0.2. So it is equal to 1.3 meters. Okay, so actually if I were to show you the answer, it looks very simplified, but actually a lot of thoughts needs to go in to find the perpendicular distance of each force. Okay, so when I write it like that, you can easily multiply them. So later on, this will have no moment, right? Because the perpendicular distance is 0. So this is the weight of the plank multiplied by 0.5. This is the weight of the counterweight multiplied by 1.3. So now we have to find whether each of these moments is clockwise or anti-clockwise. So for this will be anti-clockwise. Okay, because the pivot is here. The pivot is here, the force is to the left of it and downward, so it will be anti-clockwise. For WP, it is over here, right? So it will be clockwise, and for the counterweight, it will also be clockwise, right? So this will be anti-clockwise, clockwise, and clockwise. Okay, if you still don't know, you meet me in person and I'll show you the pen trick. Okay, now, is this thing in equilibrium? We have actually, when we assign the direction, we have come to step 5. Okay, step 6 is applying principle of moment. When can we apply principle of moment? When we see that it is in equilibrium. So that gives us the license to use principle of moment, which states that sum of clockwise moment is equals to sum of anti-clockwise moment. So I need to sum them up. So for clockwise moment, there are 2. So it will be weight of plank is multiplied to 0.5, and I need to add on weight of counterweight multiplied to 1.3 equals to the anti-clockwise, which is weight of the student multiplied by 0.3. Now weight of student is the one that we want to find. Weight of counterweight is actually 70 Newton. Okay, you need to get all this information from the question. Weight of the plank is actually 80 Newton. Okay, equals to weight of student multiplied by 0.3. Okay, actually I made a mistake. When I wrote here is 0.3, right? Actually the weight of student from the plank is 0.2. Weight of student to pivot is actually 0.2. So this should be 0.2. Okay. Over here, I say that he is 0.3 meters away from point A, right? But I shouldn't take this distance. I should take the distance with respect to where the pivot is, which is over here. So pivot is 0.5 from here, so it should be 0.2. I apologize for this. So this should be 0.2. Okay, so then I do my math. Okay, so if I were to do all the math correctly, I should get weight of student to be 655 Newton. Okay, 655 Newton. Okay, so now the student walks from his original position to his new position at position A. So he is actually increasing his perpendicular distance to the pivot, right? So what must you do so to the counterweight so that the plank will still remain at equilibrium, right? So it means that the moment due to student will be larger. All right, the anti-clockwise moment by student will be larger. So I need to increase my clockwise moment as well. But because the weight is fixed, I can only move the counterweight. So I need to move the counterweight nearer to B so as to increase the clockwise moment. All right. So you need to know the concept. Okay. Then they want us to calculate the vertical deceleration. So we actually have our Fnet here. So it's whenever there's Fnet, there is going to be acceleration. But because the Fnet is opposite to the direction of motion, it is a deceleration. But it's okay. Later we can do our calculation. So Fnet is 2,500. The mass is 10,000. Therefore, the acceleration or deceleration will be 0. Oh, sorry, I used the weight instead of the mass. Okay, so it should be 1,000. Don't make the same mistake as me. So it will be 2.5 meter per second square. So by right, this is deceleration, right? It should come with a negative sign because this A stands for acceleration. It should come with negative sign, but we can just put deceleration will always be positive, yeah, so we can put it as 2.5 meter per second square. So remember to make a switch. Deceleration cannot be negative. Okay, so a bicycle is moving on a straight horizontal road at a constant velocity of 3. When you see constant velocity, you must know that acceleration is 0. That means your Fnet is equals to 0. So the combined mass of the cyclist and his bicycle is 175. So M is 175. It collided with a 50 kg pedestrian who is walking towards the bicycle at a constant velocity of 0.8. Compare the forces experienced by the pedestrian and the cyclist at the point of collision. Explain your answer using Newton's law of motion. Okay. Let me... Okay, so according to the answer, the pedestrian will experience a greater change in velocity compared to the cyclist. Okay, the resultant force experienced by the cyclist with his bicycle and by pedestrian is equal in magnitude, right? Because this is like Newton's third law. Okay, so according to the Newton's second law, since Fnet equals to ma, the mass of pedestrian is lower, so the deceleration of the pedestrian is thus higher than the cyclist. Okay, the cyclist with his bicycle has a larger mass, so the deceleration will be smaller. Okay, it will take a longer time to decelerate because he has a larger mass, but the pedestrian will have a smaller mass, so the deceleration is actually much higher. Okay, sorry, this one is actually for part B. Okay, so because they are two bodies, so the force exerted by the bicycle on the pedestrian is equal in magnitude to the force exerted by the pedestrian but opposite in direction. So this is based on Newton's third law. Okay, then after that, because the force is the same but because the mass is different, okay, F equals to ma, the the larger the mass, because the force is the same, the smaller the acceleration or deceleration. So the rate of change of speed will be smaller. This is for the bicycle and the cyclist. Okay, but for the pedestrian, because the force is the same, right, because it's Newton's third law, so the mass is actually smaller, so the acceleration will be larger, right? So he will experience a larger change in speed. Okay. Okay, question 7 is about pressure. So elephant has a mass of 5,000 kg. When it stands on 2 feet, the pressure experienced by each foot is 100,000 Pascal. So what is pressure? Force acting per unit area. Okay, so calculate the surface area in contact when the elephant is standing on 2 feet. Now, pressure equals to force over area. We know that the pressure experienced by each foot is 100,000. So, instead of multiplying by 2, okay, I just keep the pressures as it is. The force, take note, it should be 5,000 times 10. Alright, because this is mass, I need to change it to weight. W equals to mg, so it's equals to 5,000 times 10. Okay, now this is the total area, which is of 2 foot, right? So area then is equals to 5,000 times 10 becomes 50,000 over 100,000. Therefore, I'll get 0.500 meter square. Okay. So some of you may ask me, hey, why don't we multiply the pressure by 2? Because the pressure is equally spread out among 2 feet. So whether is it the 1 feet, the left feet or the right feet, it will still be the same pressure because they have a total area of this, which is supporting this force of 50,000. Okay, question 8. It shows a simple mercury barometer used to measure the pressure of atmosphere at sea level. Height h is the vertical height, okay, from the top of the meniscus to the mercury. Now state what happens to height h when the diameter was reduced. It should be no change because it doesn't matter, right? It doesn't matter what is the cross-sectional area. Pressure equals to rho gh. So the density no change, g no change, and the pressure, atmospheric pressure, doesn't change, so the height doesn't change. The diameter of the tube or cross-sectional area is not in this formula, so it doesn't have any effect. Now what happens if additional mercury is added? So this height h is from meniscus to this side, to the mercury level, right? This h is the difference in height, so there is no change again, okay, because it is not an absolute height. So even if I add in more, this meniscus will just go up and then I will still have the same h. Okay, so please take note. Now the barometer is brought from sea level to the top of the mountain. So when this is brought up, the PATM will actually decrease. Now PATM we can calculate using rho gh. So density no change, g no change. So if PATM decreases, this height will decrease. Okay. Now the vacuum in the tube was replaced with air. Okay. So now, if it's replaced with air, remember when I told you, if there is a surface that is acted upon by pressure, please indicate it. So now we have P air. Okay. So where do we have same liquid, same level, same pressure? This is P atmosphere, same liquid, same level, same pressure. So PATM is equals to, before that was rho gh, okay? But now your PATM is equals to, PATM is outside, inside is this point. So it's based on the height of the liquid, rho gh, this height, plus P air. So now this height will become PATM minus P air. Okay, so this value actually decreases. This remains the same, this remains the same. Density, energy remains the same. Therefore, the H will now be lesser. The H will decrease. right? Because previously it was PATM equals to rho GH. This H reflects the amount of mercury that is pushed up by the PATM. But because now there is air in the vacuum instead of just vacuum, so my PATM will need to be subtracted by my pressure of air. So with that, then my density no change, my G doesn't change, so the H, the height will change. Alright? Okay. So this is hydraulic press. Actually, this one was in our tutorial. I don't see anything that is difficult because the area is 20 cm square. They give us area. If it's diameter or radius, then I need to be careful. Okay, so this one, the answer should be 100 Newton. F is 100 Newton. Okay, I will not explain too much. If not, the video becomes excessively long.